yesterday we kind of talked about taking one sample from one population. Today we're going to talk about comparing two samples from two populations. So like, what is the difference between the proportions of two different populations? So in other words, let's say I want to definitively say that I'm going to take samples and use those samples to decide, does Grandview do more homework than Bexley? And of course, because we're amazing, we do, right? So the first thing we might ask ourselves is, this first statement says, hey, at GHHS, 70% of students did their homework last night. Is that a P or a P hat? It is a P. And what we're going to do is use these little subscripts because to help us keep track of what's Grandview versus what is Bexley. Okay, so we're going to say that the P for Grandview is 0.7, and that the P for Bexley, as we keep reading, is 50%. We're going to call that 0.5. Okay, so let's go ahead and pretend that Mr. Stork and Mr. Bexley counselor guy are having a competition. So they're each going to take a sample of students from their schools, or from a certain day, okay, and look at those percentages. Cool? Now, is Mr. Stork's percentage going to be 70%?
Probably not.
It'll probably be pretty darn close to 70%, but, I mean, it could very easily be 72%, and we wouldn't bat an eye at it, yeah? And likewise, is the Bexley counselor's sample going to be at 50%? Not necessarily. Like, it could be like 51 or 52%, or it could be 48 or 49%, okay? So they're each going to take a sample, and then they're going to subtract their two P hats. That's what I want us to envision. Everybody good so far? Okay. Now, what else do we know? The sample size from Grandview is 100. So I'm going to say NG equals 100. And I'm going to say NB for Bexley is 200, since Bexley's counselor is taking 200. All right, so the first question, we're only going to focus on what would the distribution of the possible P hats that we get from Grandview, what would that distribution look like? So when we talk about that, we're talking about shape, center, and spread. Okay, so for the Grandview one, we had, what was the rules for the P hats to be normal? Do we remember that? NP and N 1 minus P. Yeah? What about those? They have to be greater than or equal to 10. So for Grandview, we would do 100 times 0.7, which is 70. And then 100 times 0.3 is 30. Those are greater than or equal to 10. So we can say that the distribution of Grandview P hats is approximately normal. Okay? What about the center of those P hats? What would that be? 0.7. It matches whatever that population proportion is. Okay? And the standard deviation of the P hats? Technically, these are P hat G, by the way. What would that be? We have to do that fancy square root formula. Which, again, eventually that will flow. You haven't used it enough yet that it's going to just flow for you. But it will, I promise. .0485 is my guess, Macy. Are you sure? .058, yeah. I already know the error in my reasoning. It's my fault. My fault, guys. I had bad reasoning. I knew it was close to .05, but I assumed lower when I should have assumed higher.
It is 458.
Oh, so I wasn't that far off. Cool. It'd be impossible that I heard something wrong. I never make those kinds of mistakes. Okay. So you guys, so we could draw this picture, right? And I'm just going to put like a p hat g here. Centered at 0.7, the standard deviation being 0.0458. And then can we think through what Bexley's would look like? We'd have 200 times 0.5, and then another 200 times a different 0.5, technically. So are you guys with me that approximately normal again? So I'm going to start drawing this. And the mean of the Bexley p hats would be 0.5. The standard deviation would be the square root of 0.5 times 0.5. All over 200? Is this feeling okay? I feel like I'm kind of going fast, but is this making sense? Having gone through what we did yesterday? Okay. And, .038. So let's say we had a competition between Grandview and Bexley, winner take all of something, whatever the prize we choose it to be, okay? And I wanted, what is the probability that Grandview does better than Bexley in our samples? That the Grandview sample has a higher percentage than the Bexley sample. Is everybody with me? So essentially I want to find what is the probability that the p hat for Grandview is bigger than the p hat for Bexley. Now, big idea. If I want to find the probability that one variable is bigger than the other, are you with me that this would be equivalent to that when I subtract Grandview's minus Bexley's, my response is greater than 0. That if Grandview is bigger, if I take a bigger number minus a smaller number, it'll be positive. And if I ask that question the other way, was the probability that Bexley beats Grandview, that would be that Grandview minus Bexley is negative, right? Because then it would be the littler number minus the bigger number would be a negative response. And that 0 is the boundary. And think of it as 0, like nobody wins. Cool? So now we got to think through, what would the distribution, and this is the big idea of where we're trying to get, what would the distribution of p hat Grandview minus p hat Bexley look like? So we're subtracting two variables. This does tie into stuff we did in Unit 4. Okay? If my two parent variables are normal, their difference will be normal. Is everybody good? Okay, and I want to make sure we understand what this graph actually represents. So let's go ahead and say that after their samples, p hat Grandview could, let's go ahead and say Mr. Stork actually takes this sample, okay? And the p hat is 0.72. And the p hat from Bexley is, we'll say 0.53, okay? Everybody good? So what would my difference in that particular case be? It would be 0.19. Everybody good? Now, on average, what's the mean of those differences going to be? No. Well, they're both on average going to be 0.7 and 0.5, so their difference is going to be 0.2. Yeah? And this one particular set of samples would be this value on the data, on the normal graph. Everybody good? All right. Hardest question I'm going to give you, no. One of the more challenging questions I'm going to give you today. What will happen for my new standard deviation? It's going to increase because I now have variability from two different groups, right? Or uncertainty from the Grandview percentage, uncertainty about the Bexley percentage, more uncertainty. So a higher standard deviation. Do you guys remember that Pythagorean rule that we were dealing with before when we subtracted two variables? Do you guys get what I'm saying here? Okay, so to find the standard deviation of the distribution of differences, I would take the 0.0458 squared plus the 0.035 squared, and then I would take the square root of that. Do you guys remember having to do that? This is the same thing where both my p hats are variables, right? It's almost like we have two buckets. We have this one and then a different one for Bexley. Okay? Everybody good? And guys, what are you getting as your standard deviation when you plug this in? Okay, I'd buy that. Now, what tells me that I'm using these formulas is I have two different samples I'm drawing from two distinct populations. Okay, if I only have one sample, the rules I follow are the ones we learned yesterday. Does that make sense? If I have two populations, then these are the rules I follow are about what we're about to do. Okay, so this one was normal because of not the. This one was normal because of this entire row. So the normal condition worked for Bexley and Grandview, so it's good. Okay. First of all, when we're comparing two populations, we never add them. We always subtract them. Okay, because to compare two things is looking for the difference. Cool. All right. So here. So before, when we had one distribution, our normal condition was NP, N1 minus P, greater than or equal to 10. If I have two populations and I'm drawing two samples, We need that for population 1 and for population 2. So it is the exact same condition, you just have to check it for both groups. So just like here, the mean is just going to be the difference between the two population means, and the standard deviation, again, this would be on your formula sheet, okay? The standard deviation is the square of the first standard deviation times the square of the second standard deviation, yeah? So the first standard deviation was the square root of P1, 1 minus P1 over N1. But then I'm going to square it, right? Because of that Pythagorean thing we do. So here's what I need you guys to see. If this is squared and this is a square root, do you guys see that those cancel each other out? Is this okay? All right, so really the fancy formula goes like this. You don't need the square root and the squared. So it's going to look like P1, 1 minus P1 over N1 plus P2, 1 minus P2 over N2. So it's like that same standard deviation formula. You got one fraction for each population that you're subtracting. This is the back page of your formula sheet. And while I didn't give you a formula sheet on the quest for next week, I will let you use yours. Your quest is a week from tomorrow. Okay? I will let you use your formula sheet on that. Does that make sense? Okay? So, and what, you might forget your whole formula sheet. Did you guys see how I have a whole stack of them? Okay? There's never going to be a time where you won't have access to the standard deviation formulas somewhere. Okay, that you'll always get. The normal condition, no. So you really want to make sure you know that one. Okay. All right. Let's compare calculus to stat students to calculus students. All right, tell me something I know after reading the STEM part of the question. This is the STEM. Anything? PS equals 0.65. And PC. Okay. NS would be. NC would be 40. Cool. Now what? So, describe the sampling distribution would mean we have to describe what? Shape. center, and spread. Okay, so shape. We would do 35 times 0.65, 35 times 0.35, 40 times 0.76, 40 times 0.24, I don't know what any of these answers are.
0.65 times 35 is
22.8, so that would make this 12.2. I think. Because they should add to 35.
0.76 times 40 is
30.4 and then 9.6. Uh-oh. Is this approximately normal? Technically, no. Because? The 9.6. Because that one's below 10. But for our intents and purposes and you guys getting what I need you to get out of this question, what we're going to do is say close enough. If it were the AP exam, that would not be close enough. Can we agree on that and just not make fun of Miss Meister for, again, writing a really terrible problem? Okay. Now, what would the mean of this distribution be when I subtract these two? And again, I'm specifically saying statistics minus calculus. It would be negative 0.11, I think. Does that feel right? And we got that. Oh, technically, you should do this. Does it make sense to have a negative mean? Is that okay to have a mean that's negative? For a difference? Yeah, because like the difference between two numbers can be negative, yeah. All right, what about the standard deviation? Yeah, 0.105. Yeah, that sounds okay. For a second, I thought you said 1.05, and that would not feel good. Yeah. All right. How are we feeling? On a scale of 1 to 5, just show me kind of where you're at. Okay. Cool. So if I want to know what is the probability that the difference is less than or equal to negative 0.02? You guys, where is negative 0.02 on this graph?
To the right.
Are we all good with that? And then this feels familiar. What are we getting?
0.8 times 4.
So it's like, are you guys with me? That means we had 0.8, and I'm going to just round that to like easy percentages, okay? Are you guys with me that this is essentially saying that 80% of the time we're going to get something lower than the 0.02 and 20% of the time we'll get something above? So is that a real surprising number? This feels like it's like 20% of the time is 1 in 5, right? Like it's not crazy higher than, because you could get higher than it 20% of the time. Okay, so when answering these questions about would you be surprised if, okay, one of the things you want to start doing is tying that to probabilities of that value or more extreme. Okay, so the negative 0.02 is larger than expected. Are we all comfortable with that? The expected percentage is negative. The expected difference is 11%. Okay, but I'm going to say, but not super larger. I know that doesn't actually make sense. Because 20% of the possible differences are larger than that 0.02. Like it's not a super rarity. Okay? Now, if that negative 0.02, what if this had been 1%? Then I'd be pretty surprised. Right? Like if this probability, like 99% of the time you're going to get one over there, get one smaller than it. So, man, only 1% are that far away. That would suggest being very surprising. So then our general rule of thumb that is like something is surprising if its probability is less than 5%, 0.05. We'll talk about that a heck of a lot more next semester. Okay. I'm going to stop you. Okay. So tomorrow you have your quiz number 10. It is only on the yellow sheet. Okay? So none of the specifics phats stuff is on that. Okay? You also have homework 5A. When's that due?
Monday.
That is your main way of knowing do you understand the phats stuff. Okay? Now, what I also have for you, and I'm comfortable giving it out at this point, is the quest next Friday has a review sheet just like every other quiz would have. And we're about halfway through. You can do the front half of this page after getting through these notes. And I gotta double check, but I'm 92% confident that the key to this is already up on Schoology. It's definitely already written, so I just need, if not, I just need to scan it and upload it. So if you wanted to just get some more practice with the PHAT stuff, this is what I would do, because this is how you're going to be asked about it on the quiz. Quest. Okay? Also, I give you twice as much space on the quest.
Thank you. Do we get a hint for C on the homework?
Yeah, the hint for C on the homework, thank you for reminding me, is when you look at part C, if they differ by more than 0.05, okay, that goes in both directions. So more than 0.05 would be smaller than negative 0.05 and larger than positive 0.05. Do you guys get what I'm saying? There's two sides to where you would shade on that particular one. And it feels a little bit weird.